Okay, so this week we're talking about systems of equations. And if you're going into engineering, you're definitely going to need these skills because you will use them in some of your higher level engineering courses where they have a lot of math involved. And there are three basic ways to solve a system of equations. We've got substitution, elimination, which is also called the addition method, and then there's graphing. And then next week we'll learn about matrices, which is a fourth way where you're converting it to a matrix and then you solve that way. So I'm covering systems using substitution, which is a very popular method to solve. So first, what is a system? So we have a system when we have more than one equation that we're trying to find a solution for. So we are looking for a solution that works in all of the equations in our system. And we indicate that we have a system with the curly braces. And then you put your equations like to the right of it. So we usually have a two equation system. And in order to solve something with two equations, we have two variables. You basically want to have the same number of equations as you have variables so that you can solve and get a solution. So when we're solving a system, we'll have X and Y and two equations. And so your solution is an ordered pair, X comma Y, between looking for the intersection between those two. You'll also see these called as simultaneous equations or simultaneous systems. That the term simultaneous appears a lot in engineering. So you'll hear people who are more on the engineering aspect calling them simultaneous versus mathematicians that just call them systems. So just a side note that those are basically the same thing. So when you're solving by substitution, you're basically taking one equation and plugging it into the other. So we've got more than one variable. So you have to pick one of your equations, and then you pick one of the variables that you're going to solve for. So you either take one of the equations and solve for X or solve for Y, and then you plug that into the second equation. And then that will give you an equation with only one variable left to solve for. And then, so then you solve that. And that gives you half your solution because your solution is two numbers, an X and a Y. So you get half of it. And then you need to plug that answer back into one of the equations from the very beginning to get the second answer. And we call that back substitution because you're plugging it back into what you started with. And then once you have your second number, you write your answer as an ordered pair, X comma Y. We usually put them in alphabetical order. So if you use different variables, you just put them in alphabetical order. So this is the most basic kind of system, the easiest that's to solve. And I see a lot of people that are saying, well, I don't know what method I use to solve this system. And you're using substitution. So we've got two equations here, y equals 2x plus 2 and y equals 6 minus 4x. So when you're using substitution to solve something like this, you're just setting one equation equal to the other because you've got one solved for y, and you know that that's going to be the same y that's in the second equation. So if they're both equal to y, then they're both equal to each other. So you just set them equal. 2x plus 2 equals 6 minus 4x. And that is the substitution step. You're substituting one of the equations in for y in the other equation. We're basically taking the first equation, where y is equal to 2x plus 2, and plugging it in for y in the second equation. And that's giving us 2x plus 2 equals 6 minus 4x. So once you're here, and then you just solve for x. So now it's just simple algebra. And whether you put your x on the left or the right, it really doesn't matter. I'm sure that you guys can solve this on your own and probably even beat me to solving it. So you are welcome to solve it on your own and type that into the chat. I'm going to go through and solve and show every step here. So I like to move my x to the left, so I'm going to add 4x to both sides, which gives us 6x plus 2 equals 6. Then I need to subtract 2. And we get 6x equals 4. And then we divide both sides by 6. So we get 4/6, but that's a fraction that can reduce to 2/3. So we get x is equal to 2/3. So we've got one answer here, but this is half of the solution because we need to find y. When you're solving a system, you got two equations, two variables, and you need to find the answer for both x and y. So the back substitution step would be taking that answer 2/3 and plugging it back into one of the equations. So you can either put it into the first one, y equals 2x plus 2, or you can put it into the second one, y equals 6 minus 4x. And you should get the same answer in both equations here. So that's a way that you can check your work, is to plug it into one and then plug it into the other and double check you get the same value for y. And if you don't, that tells you you made a mistake somewhere else, like you made a mistake finding your x. So there is a way to kind of check yourself and see if, make sure you didn't make any errors with your arithmetic. So I'm just going to plug it into the first equation because it's the first one. Sometimes I'll look at the equations and see which one looks like it's going to be easier to plug it into, but either one here, we're going to end up having to deal with fractions. So I don't think there's an advantage of one equation over the other, so it doesn't really matter. So we have y equals 2x plus 2, and I'm going to replace x with 2/3. So now you're just going through arithmetic. So 2 times 2/3 is 4/3. And in order to add 2 to that, I need to have a common denominator. So that would be, I need to multiply the 2 by 3. So that will give me 6/3 here. So I need to make sure that these have a common denominator so that I can actually add them together. And that gives us 10/3 for our final answer for y. So when we write an answer, you always have x first and then y. So it's going to be 2/3 and then 10/3. And we'll just check our work with the other equation just to make sure that I didn't make any errors here with my arithmetic. So if we plug 2/3 into the second equation, we would have y equals 6 minus 4 times 2/3. So again, I'm going to have a denominator of 3. So I need to rewrite the 6 as 18/3. And then that's going to be 4 times 2, which is 8/3. And then that gives us the same answer, 10/3. So that is kind of a check there to make sure, okay, I got the same answer for y by plugging that 2/3 into both equations. So I know that that is correct because it does work. It works in both equations. And that's what it means to be the solution to a system. Is your answers have to work in both equations. So are there any questions? Make my 2 a little better here. All right. So this is a pretty simple setup. One of the problems on the application assignment, you basically end up doing something like this. You set them equal to each other. And so when you're writing your journal, the journal asks, what method did you use? And for that one, you are using substitution. So here's another one. And this is like, so that was like your easiest type, was then you just set them equal to each other. This is your second easiest way or arrangement of the equations. And we have y equals x minus 2, and then 6x minus 5y equals 16. So one of the equations is solved for a variable. So we just need to take that, we have it solved for y. So then to do our substitution, we're going to plug that into the second equation. So where you see y in the second equation, you're going to write x minus 2. So it's set up to do a substitution. You have one of the equations solved for a variable. You just need to plug it into the other equation, and then you're going to be solving. So I say this is the second easiest because you do have to do some distributing. The other one, all we had to do is set it equal to. You have a little more steps here when you do this. So we have 6x minus 5, and then instead of y is equal to x minus 2. So we have 6x minus 5 times x minus 2 equals 16. And so now, just like the other one, we're just solving for x here. So you are welcome to do that on your own. Type it in the chat, you know, kind of test yourself, see if you get the same answer I do. So I'm going to distribute my 5. So this is minus 5 times x, and then I'm going to get a plus 10 equals 16. It's the negative 5 times negative 2. So 6x minus 5x, that's actually just x. So we have x plus 10 equals 16. And then all I need to do is subtract 10 for both sides. So this is not bad at all. We get x is equal to 6. So again, you're not done because you only have half of the answer. You need to get y as well. So you can plug 6 in for x into either equation, the y equals x minus 2 or the 6x minus 5y equals 16. Our previous example didn't matter which one we plugged it in. It was roughly the same amount of work. Here, I would plug it into the first one because it's solved for y, so it's going to be less work. If I plugged it into the second one, you're going to have to do some multiplying. You got to move things to the other side. You'd have to divide things by -5. It's going to be a lot more work. So you want to kind of look at your equations and say, well, what is the smartest equation to use to plug this in to kind of cut down the amount of work that I have to do? And so that would be the one that's solved for y. So we have y equals x minus 2 and x is 6. So it's just 6 minus 2. And then that just literally gives you 4. So, you know, couple steps. Yes, good comment. So remembering that your subtraction is like adding a negative really helps when you're distributing. So one thing with solving systems is that it's very easy to make a mistake with your signs. Very, very easy. So if you are one of those people that makes mistakes with signs, anywhere you see subtraction, you can write it as adding a negative. And that can really help to make sure that you get your correct signs, because then you can see that it's a -5 times a -2. And it just really helps when you're distributing. So that is a good point. And I do recommend doing that for anybody who struggles with signs, is to turn your subtraction to adding a negative. Really helps. So, okay, so we've got, I solved for y. We have our answer here, 6, 4. Now, you may want to check your work, you know, to make sure that you didn't make any mistakes. If you get whole numbers like this, it's very unlikely that you made a mistake, because usually we design the problems to come out to whole numbers. So if you get something with fractions, that's usually one you might want to be like, let me double check just to be safe. Though that doesn't mean you won't get problems with fractions. I mean, this one here came out to be fractions. So if we were to check our work, we would check it in the other equation, the other one that I didn't use, the 6x minus 5y. So the best way to check your work in there is, instead of just plugging in your x and then solving for y, is to plug in both of the numbers. So instead of 6x, I would do 6 times my x of 6 minus 5 times y, and my y was 4, equals 16. So this would give us 36 minus 20 equals 16, and that checks out. 16 equals 16. So when you don't have something that's like solve for y, like if I go to this one, it was easy enough to just plug in my x again and then see if I got the same y value when I was checking my work. If it's not solved for a variable, it's a lot easier to just check your work by plugging in both numbers and then see if that second equation checks out. Now, you want to be very careful. When you're checking your work, don't use the equation you use to get the second answer, because then you're not actually checking that it works in both equations. You're just checking that it works in one equation. A solution to system works in both. So because I use the y equals x minus 2 to find y, I need to use the other equation for my check to make sure that the answer works in both, because I used one of them to solve, so the other one I have to use to check. So I've seen people check it back into the original problem that they used to solve it, and then they don't actually find their error because that was what they used to solve, but they didn't check to make sure it works in both equations. So just something to kind of pay attention there is to make sure that when you're checking, you have to use the other one. Are there any questions? Three terms. Well, I'm not going to do any x, y, z in this one. I'm just sticking with the two variable x and y, because I have a whole separate video for x, y, and z, and those are long enough that you need a separate video for that. So if you're waiting on those, like 3 equations, 3 variables, you're going to want to check out my videos, because I have that separate, because it's enough. It's hard to keep track of. So this example here, I've got 2x plus y equals 9 and 3x minus 5y equals 20. So this is like the 30 type of problem, 30 easiest, where neither equation is solved for a variable, but you can easily solve one of them for a variable. So the first equation, it's like one step to solve that for y. And then I can plug it into the second equation. If you wanted to, you could solve the first equation for x, though I would not recommend that, because you would end up with a fraction, because you would have to divide things by 2, and 9, you would get a 9 over 2, and that would just be gross. You could solve the second equation for either x or y. If you solve for y, you're going to get a fraction, because you're going to end up having like a 3 divided by the -5. If you solve for x, you're still going to end up with fractions. And your goal when you're solving by substitution is you want to make it as easy on you as possible. So try not to create fractions if you don't have to. So it's going to make it harder. So just the most natural thing to do is to take that first equation and solve it for y. And then once I have that, I can plug it into the second equation. So part of solving a system is thinking through and kind of looking at your equations and kind of mentally thinking about, okay, if I start dividing by these coefficients, is that going to get fractions? If so, let me not use that one. Though sometimes you can't avoid it. So the first equation is 2x plus y equals 9. And we want to solve for y, so I can put that into the second equation. So I'm going to subtract 2x for both sides. And so I get y equals 9 minus 2x. Then I'm going to take the second equation. So you need to take the equation you haven't touched yet. And I'm going to substitute in for y, 9 minus 2x. So as these equations get a little more complicated, you can see that you have more steps to do. We keep adding more steps. So, and actually these subtractions, I'll add them as adding a negative just to make things a little bit easier there. So I have 3x, and then a negative 5 times 9 is a negative 45. Negative 5 times negative 2 is a 10. So I got 10x equals 20. 3 plus 10 is 13. So I'm going to have 13x minus 45 equals 20. And then I'm going to add 45 to both sides. Now, if you catch any math errors, let me know. I will check my work, just to be safe, but it is a Saturday, so my brain's not at full speed. So if I do make any errors, it's quite possible. So we have 13x, and then that's going to give us 65. So now we're dividing by 13, and I think that's going to be 5, if I am remembering my math correctly. But I'm going to double check because dividing by 13 is not common. 5, okay. That's a good sign. I didn't get a fraction. So we get x equals 5. So now we have half our answer. We need to find y. And so we can plug it into the 2x plus y equals 9, or we can plug it into 3x minus 5y equals 20. But we can also plug it into the 2x plus 9 equals 9 that we solved, the y equals 9 minus 2x. And that's what I would recommend you do, is that you then plug it into the one that's solved rather than one of the two original, because it just makes it easier. You just have to do some arithmetic there, assuming that you solved that original equation correctly. If you solve for y wrong, then this won't work, but you'll find that out when you check your answer. So we have y equals 9 minus 2 times 5, which is 9 minus 10. So we get -1. So remember alphabetical order. So we've got our x first, which was 5, and then our y, which is -1. But you do want to check your work. And so you do not check your work in the 2x plus y equals 9, because we just used that equation. We want to check our work into the 3x minus 5y equals 20. So 3 times x, which is 5, minus 5 times y, -1, is equal to 20. So we have 15 plus, oops, I almost wrote 6, plus 5 equals 20. Good, that comes out to 20 equals 20, so our answer works. So it doesn't take that long to check your work. It's only 3 extra steps. And it's just, a nice comfort knowing that, okay, we've got a lot of moving parts here. I didn't make any mistakes. One of the most common mistakes is just sign error somewhere. Any questions so far?
Hey, Stephanie,
Yes.
can't you check sometimes but with your graph also? Like
Yes, you can.
I like to do that. Sometimes it's more visual.
Yes. If you get whole numbers, I definitely recommend, or graphing is a great way to check your answer. It's harder to check your graph when you have fractions though, because like a graphing calculator will give it to you in decimal form. And so it's a little harder to see if you've got actually the same answer. But let me bring up Desmos here. So when you're checking your work with graphing, you want to type in the original equations, not anything that you solved with. So you type in the very first equations that you have. So we have 2x plus y equals 9, and then 3x minus 5y equals 20. And then you can see where they intersect. And if you can't see it, you can, scroll, zoom out or whatever. When you click on one of these lines and then hover over the intersection point, it will label it for you. And so that's another way to check your work, is to say, okay, 5 and -1. So graphing is great for checking your work with whole numbers. Now, if you are going into engineering, I will tell you that often when you're going to be solving systems, you're not going to have whole number answers. Usually you're going to have some decimals, you're going to have to approximate. So checking your work from with graphing is going to be a little harder, because you're going to have to think things may not be exactly the same due to rounding. So just as a side note there, because once you start getting into actual applications of this, real world problems, things are not always clean like this. And so just if you are checking with graphing with real world problems, they might be close, and you're kind of looking, are they rounding to the same point? So if they round to the same point, then you can consider that a check, because they may be a little off due to rounding. And I usually recommend, when you start doing those more complicated problems, use as many decimals as possible to eliminate rounding errors, because the more decimals you use, the fewer places where you're rounding, and rounding tends to accumulate. If you're rounding and then you're rounding again, those errors accumulate. Or if you can write it as a fraction, that's best if the numbers can be written as fractions. Sometimes they can't be, but if they can, that is the best way to do it, so there's no rounding errors. And speaking of rounding, how far do you want us to check for that fifth? Check the fifth, fourth digit, go to the fifth, check the sixth. So for most of what we are doing in this course, 2 decimal places is fine. Because, most of the application problems that we are going to be working with are, a lot of them involve money, and money has 2 decimal places. So you're going to, anything that involves money, whatever your answer is, you're going to have 2 decimal places, you're going to have decimals there. And so if they're matching rounded to the second decimal place, then you're good. I know there's some mixture problems with percentages, and those, when you've got like a mixture, you're like, okay, and you don't have a set number of decimal places to round it to. So for those, I recommend trying to do it as a fraction if possible. And if you want to, instead of check fraction wise, want to change it, check it with rounding, two decimals is still plenty. So 2 decimals is still completely fine for our purposes. Once you're getting into, definitely higher level classes where you're going to be dealing with this stuff, like I know ET 310 is the big engineering class that uses a lot of what we cover in this class. It's using systems and equations. You're often solving things that don't come out to nice fractions, so you have to round. For that class, I usually recommend 3 or 4 decimals to round to, just to make sure that you've got enough accuracy that it's not going to run into issues later on. But for this class, 2 decimal places is completely fine. for other questions. Okay, well, I've got one more example here. And then we have free time. So if there's questions about things on the homework, whatever that you want to ask about, we can use that free time to talk about those. So here I've got 0.5x plus y equals negative 3.5, x minus 3.2y equals 3.4. Now this is a good example to talk about rounding. If you have a problem and you're given specific decimals, like if you're given a problem with like 2 decimal places, round to 2 decimal places. Here we have 1 decimal place, so we're going to want to round to 1 decimal place just to be kind of match in line with the numbers that we have here. If you're doing intermediate steps, sometimes you might want to use 2 decimal places, an extra spot in all intermediate work, and then round your final answers to 1 spot just to make sure that you've got accuracy here. So that's a general rule, is like if you like here, we could just any work along the way, we might use 2 decimal places and then just round our final answers to 1. So this type of problem, we can choose to solve for y in the first equation, or we can solve for x in the second equation. I'm looking at this, there's not really an advantage to one or the other, because they're both probably equally as easy. I'm going to actually solve for x in the second equation, just because all of the examples we've had so far, we've had solve for y. So I'm going to do it differently. I'm going to solve it for x, so that way you can get a view of what that would look like. So the second equation, I want to be consistent with my colors here. We have x minus 3.2y equals 3.4. So I'm going to solve this for x, which means I'm going to add 3.2y to both sides. And if you wanted, you could solve this for y, but then you're going to be dividing by a decimal, and I would not do that. So we get x equals 3.4 plus 3.2y. So now we're going to go to the first equation, and where you see x, you're going to replace it with 3.2 or 3.4 plus 3.2y. So we have 0.5 and then x, so that's 3.4 plus 3.2y. Make sure you've got all of your right numbers. Then plus y equals negative 3.5. So one common mistake I've seen is sometimes if it's like in a situation like this, people might forget to write the plus y, because they've already wrote something with y and they kind of forget about the other part of the equation. So if you find that you've made an error somewhere, double check that you didn't forget a part of your equation when you did the substitution part, because that is, in addition to like making sign errors, forgetting parts of the equation when you do the substitute is common as well. So sometimes I'll do some color coding or highlight, maybe I'll do one equation in one color, the other equation in another, so you can kind of make sure you've got all of your pieces. So here we're going to multiply. And so I'm going to have 0.5 times 3.4. So luckily that doesn't come out to lots of decimals. And then 0.5 times 3.2 is 1.6. So I have 1.7 plus 1.6y plus y equals negative 3.5. Now, had my multiplication not come out to like a nice number that just I didn't have to round, I might round to 2 decimal places just to make sure that I have enough places of accuracy. So now the 1.6 plus y is going to be 2.6. So 1.7 plus 2.6y equals negative 3.5. I divide 1.7, not divide, subtract 1.7. At least I wrote the correct thing. We get 2.6y equals, and I always do decimals on my calculator because I do not trust my brain to do them correctly. So that gives me a minus 5.2. And so now we're going to divide by 2.6. And I think that's 2, negative 2. Y equals negative 2. Okay. So everything we've done so far, when we got to y, we were done. But in this case, because we solved for the other variable, we're only halfway done. We don't have our number for x. So now I'm going to take that equation that I solved for x and plug in negative 2 for y. So we have x equals 3.4 plus 3.2 times negative 2. So it's 3.4. And again, I could do this in my head, but I just don't trust myself when it comes to decimals. Minus 6.4. And then we get negative 3. So when you write your ordered pair, make sure you do it in alphabetical order, x first and then y. So our answer is going to have the negative 3y and then negative 2. And you can check your answer by plugging in those numbers into the first equation, the 0.5x plus y equals negative 3.5. If you really wanted to, you could redo the whole problem, but solve for y instead and check your answer, though that's a lot of work. Or, like was mentioned earlier, you can graph your answers because we got whole number answers here. So it'd be relative easy to check your answers and see if the intersection point is negative 3, negative 2. So that's a good way to check your work there. Any questions? And if you don't have questions on this, do you have questions on other things? Homework, maybe something you saw in the textbook you want to work through? Any other particular questions? Everything was graded. I think only one person I need somebody to resubmit because the stuff was sideways. I can't, unfortunately, Blackboard doesn't allow me to rotate. So, but I think everybody else's submissions, I was able to grade them pretty, I didn't have any issues seeing anything. No questions? Shane, you were asking about 3 terms. Do you have a particular problem you want me to look at?
Yes, I do.
Okay.
I've tried it. I bet I've wasted 8 leaves of notebook paper. I've watched the video. I've tried to follow it, but somewhere my numbers get so much bigger. And it's just the easy one in the textbook.
All right.
One of the examples in a textbook. And I think it's throwing me off because 2 of the variables are automatically canceling each other out while I'm trying to cancel another one out.
Which example is it? I've got the textbook open so I can.
Let me see a piece of paper that I ripped out.
And then I can write it down and we can walk through it.
It was like one of the very first ones where it starts off x plus y plus z equals 6. And then 2x minus y plus z equals 3. And 3x
Okay.
plus y minus z equals 2.
Okay, so make sure that I have this written correctly. X plus y plus z equals 6. 2x minus y plus z equals 3. 3x plus y minus z equals 2.
Correct.
Okay. So if we solve this with substitution, we have to decide, are we going to solve for x, for y, for z? We can also solve this with elimination, which is another method, but let's do substitution. And I'm going to solve the first equation for z. And I'm only picking z because we're used to solving equations with x and y, and people tend to misread their z's as 2's, which is why I write them slightly different. So if we solve for z, that will get rid of z in our equations, and then you're less likely to make a mistake reading your z as a 2. So, anything to kind of eliminate possible issues, that is the way to go. So I'm going to take that first equation. We're going to solve for z. So basically, you're going to subtract x and you're going to subtract y from both sides. So we get z equals 6 minus x minus y. Then when we substitute that in, we're going to substitute it into both equations. So in the second and the third equation. So we're going to do 2 substitutions at the same time. So we have 2x minus y plus z, and z is 6 minus x minus y. And then the second equation, we have 3x plus y minus z. So it might help to do that minus as a -1. And then you are distributing across the 6 minus x minus y. And then that equals 2. And we're going to just simplify these. We're not going to solve for x or y yet. We're just going to simplify the left and the right side. And we're going to rearrange it so that all the number parts are on the right and then our x and y are on the left. So my first equation here, 2x minus x, that is x. -y minus y is minus 2y. And then I have plus 6 equals 3. And then I am going to subtract 6 from both sides. And this gives me x minus 2y equals -3. Second one here, I need to distribute first. So I have 3x plus y minus 6 plus x plus y equals 2. So now I'm going to combine like terms. We have 4x plus 2y minus 6 equals 2. I'm going to add 6 to both sides. And I got 4x plus 2y equals 8. So you had mentioned that you were solving this and you ended up having variables disappear. So that is very possible because when you're solving a 3-variable system, there are lots of ways that we could do this. I could solve the first equation for x and try to get rid of x. I could solve the first equation for y. I could solve the second equation for either y or z. I could solve the third equation for y and z. There's lots of different ways to do this. And you still ultimately get to the right answer. So if you're solving one way and you're like, I'm messing up somewhere, maybe try, starting in a different place, because maybe if you can't find your error that you're making, starting in a different place might end up being easier and kind of correct itself or whatever as you're working through. So now we have 2 equations with 2 variables. So we have x minus 2y equals -3, and 4x plus 2y equals 8. So now we're going to take those two equations and we're going to use substitution again. We're kind of repeating the process. So we had x, man, I can't even remember, minus 2y equals -3. 4x plus 2y equals 8. So now we've got basically a second system here that we're solving. And I should have, let me just make a correction here. I really need to have this curly brace to make it indicate that it's a system and not just random equations. So when you're writing your work for the assignment, make sure you have that curly brace surrounding your equations, that you're writing very clearly what the equations are you're starting with. Because on some of the homework problems, you could potentially write the equations slightly different. And so I need to see what those starting equations are so I know where your base is. And then you do need to have that curly brace to show that it's in a system. So make my correction there. So to solve this, I'm going to take that first equation and solve for x and then substitute it into the second one. So I have x minus 2y equals -3. So I'm going to add 2y. We get x equals -3 plus 2y. And now I'm going to take that x and plug it into my second equation. So we have 4x, but I'm replacing x. So it's -3 plus 2y plus 2y equals 8. So I'm going to distribute. We get a -12 plus 8y plus 2y equals 8. 8 plus 2 is 10, so -12 plus 10y equals 8. Going to add 12 to both sides. So we get 10y equals 20. Then we divide both sides by 10. We get y is equal to 2. So now I've got one answer, y is equal to 2. And now I need to plug it into what we had here for x, and I can find x. So I'm going to back substitute. So we have x equals -3 plus 2 times 2. So this is -3 plus 4, and x is equal to 1. Then now we have x and y. Then we go back to our equation right here to find z. So z is 6 minus, and x is 1, and y is 2. So I'm just making sure I'm plugging in the correct numbers. And we get 6 minus 1, which is 5, minus 2. We get z is equal to 3. And so our final answer, you write it as x, y, z, alphabetical order. So that's 1, 2, and then 3. So when the book talks about multivariable linear systems, it has what it calls Gaussian elimination, where you're trying to get all three of these variables in a very specific form so that it has like sort of an upside down staircase form. I don't necessarily always use that method to solve these systems because sometimes I think it's a little harder and it gets more confusing. It's what is nice about the way how the book explains the Gaussian elimination is that it is essentially the process that we will do next week when we have matrices. So it allows you to bridge the gap from systems of equation to matrices and be able to follow what we're doing. But while it works wonderfully with matrices, when you're doing it with variables and equations, I think it's unwieldy. And so I don't actually follow those steps when I'm just solving on my own. I will do something like I did here, where I solve one of the equations for a variable, plug it into the other two. So that way, then I get a 2 variable system to solve. And then once I have those 2 answers, go back to the original, plug it in. So it's very similar to Gaussian elimination in the back substitution part, but what's special about Gaussian elimination is that they're trying to solve the equations in a very specific way that I think when you're doing it in equation form is harder than when you're looking at it with matrices. So I don't know if that was helpful to you, Shane.
Yes, actually, because the Gaussian is what was messing me up. I watched all the videos and it was like line them up like this, attack column 1, then attack column 2, and then equation 1 plus equation 3, and I just kept losing myself somewhere in there.
Yes, yes. It's much easier when you do it with matrices next week, because it's a lot more organized than when you're trying to do it with equations. So yeah, I don't even, I have a video teaching the Gaussian elimination because, that is how the book is teaching it, but I don't actually use that method when I'm solving them. Now, if you were to check your work with something like this, you would have to, in order to check your work, the 1, the 2, and the 3, it's when you've got a 3 variable system, you can't really graph it because our graphs are 2D, and there are ways to do 3D graphs, but they're very difficult to read. So to check your work for something like this, it's best to just plug in all 3 numbers into all 3 equations and make sure it works. Because you kind of used all 3 equations to get your answers. I mean, you know that your X and Y got your Z in the first equation. So you could plug it only into the second 2 equations and check your work and skip the first equation, but you still want to try to make sure it works in all 3 of them in this case. So you're checking your work is a little bit harder because there's more to do, but you can't really graph something like this. There is a website that does 3D graphs, actually. I'll pull that up. So Geogebra is another kind of graphing website, and this does 3D stuff. Desmos doesn't do 3D. So it's this 3D calculator thing here. Okay, so it's a little slow. It's looks a little different, but it's very similar. It's, it's got some similarities to Desmos. It's a little slower, but it does do 3D. So if we were to check our work for an XYZ problem, you type in each equation here and 2x minus y plus z equals 3. And with 3 variables is actually graphed as a plane. It's a flat surface versus a line. Maybe I can change the color of these. I don't use this very often, so I don't know. There we go. Okay, I'm going to just change. Oops. The color so we can kind of see the 3 different colors or 3 different. Okay. So these 3 equations are forming this 3 flat surfaces that are intersecting at some point. And the answer is where all 3 of these intersect. So I can click and drag and kind of move in 3D space. But it's very difficult to see visually where that intersection point is. I mean, I'm looking at this and I think it's basically right there. I think. So I can type in my ordered pair. Okay, that's apparently where it is. So it's really hard to visualize and double check your work. That actually doesn't even look like it's on the green. So we might have made a mistake when we were solving. Oh, maybe it is on the green. No, I don't think it's on the green. So this would say maybe I made an error when I was doing my math, and we should check our work here because it doesn't look like it's intersecting with the green. Oh, that's because I typed in my equation wrong. Okay, there we go. So that's another thing. If you don't type your equations into the system wrong, or into the system right, yeah. Okay, it does look like it's intersecting. So your intersection point is basically where three of these flat surfaces combine, but it's just really hard to see visually. And so I don't recommend, yeah, it's a lot. I don't recommend trying to solve a 3-variable system by graphing, because you can, where you think the intersection point might be, may not be where it visually actually is. As I found out, I thought it was one place, it totally wasn't. So, but you can check your work. It just is not nice. And that's why we have these other ways to solve these that are this big. There are other questions? Is there a difference in inconsistent formulas, or it works about the same? So if things are inconsistent, you will get a contradiction somewhere when you're solving, whether there's 2 variables or 3 variables. You'll get a problem where your variables will disappear and then you end up with like 2 = 5 or something like that. And so you'll get that somewhere when you're solving. Things will start to cancel out. And so if you do get a contradiction anywhere in your solving, that means that it's an inconsistent system, that there is not a solution that works in every equation. Like you might find a solution that works in 2 of them, but not the 3rd one. It's a lot more common to find inconsistent systems when you've got 3 equations than when you've got 2, because the more equations you have, the harder it is to find a place where they all intersect in one spot. Anything else? Okay, so, I'm actually going to pull up the assignment. I sent an email yesterday with just some tips about the assignments, but I'm just going to pull it up just to do a quick overview, make sure you guys aren't missing anything. Okay, so for this first one, if you are not given variables to use, like this one says it gives you X and Y. If you are not given variables, you need to pick your letters, but you need to tell me what your letters stand for. So if you're going to pick like S for sales or C for commission, or whatever you end up picking, you need to tell me what your variables are. Even if they're X and Y, label them as X and Y, because I don't know. One person might say X is going to be the amount of sales, and the other person says Y is the amount of sales. Like there's no, so you have to, in your work, specify what your variables are representing if you're not given variables. You do have to write your systems. So if you're typing, and I noticed a lot of people were typing, you don't have to type, you can do it on paper, but if you are typing, when you go to insert an equation under bracket here, and then if you scroll down, this is how you can get a 2-variable system. And then you click it. So like you might have Okay, we're looking at salary. Maybe I'm using S for salary. Salary equals, you have two equations, like where you're doing an equation for each salary. You know, you have to type in your equation. First one would be 0.06. Let's say I use X or something like that. So this is how you want to make sure that you give me your equations before you start solving. Because I've seen people just go to the solving part and I'm like, well, wait a minute, what were your equations that you started with? So make sure you give your system with your equations. You tell me what X stands for, what S stands for, whatever your variables are. And make sure you're actually answering your questions in sentences, because these are word problems. So you should be answering in words, and make sure that whatever answer you give actually does answer the sentence. Make sure that you're following directions. Like here, it just says write a system. So you don't solve in this part. So don't solve it here when it doesn't tell you to. Here, you want to make sure you include the graph. So you can do this in Desmos and then paste your graph into here, or, do your graph by hand or upload the graph as a separate file. If you're doing your work on paper, that's fine. Make sure you are actually answering the question. Here you're solving. This is another one where you're not given your variables. So you need to tell me which variable is the 5.75%, which is the 6.25%, because I won't know if you don't tell me. Number 4 is a doozy. I do have a video that goes over how to solve this one with similar numbers. So review that video. I can always tell when somebody hasn't seen the video because they usually get the answer wrong. So review that video and keep in mind, these are real world problems. So you should be using your units, these are applications. So there are units to these problems, like dollars. This one's pounds, make sure this one's, I think is gallon. Yeah, gallons. So you should have units in your answers. You need to give me a sentence actually answering the question that is asked. Number 5 is another one that's a little tricky for people. Again, we have units here. So that one I also have a video on. So 4 and 5, let me actually go in the classroom. I think it's literally called videos for 4 and 5, if I'm remembering correctly. No, actually it's not. So let me just pull up this. Okay, so these are the 2 videos that will be very helpful for these last 2 problems. So this one's solving a 3 variable system. So this would be helpful for number 4. I think it's about halfway through. Yeah. So, okay, at about 30 minutes into this video, we do a problem similar to number 4 here. And then this modeling using system of equations just talks about number 5 in this one as well. So those 2 problems, if you watch these 2 videos, you should be in good shape for those. And I think those are all the little warnings that I need to give about the assignment, things that I'm looking for, that sort of thing. And notation is really important. Being able to communicate mathematically correctly is important, especially when you start applying the math in your other courses. You have to make sure that you're communicating what you're doing so your other instructors know, what you're doing. Math is basically the language of science. And so I really do focus a lot in writing the math correctly, making sure you're communicating it clearly, just so that you're able to have everybody understand what you're trying to say. I may get it because I know what it's supposed to look like, but on the job, you're working with people that may not know what the answer is supposed to look like. So you have to be able to communicate clearly to them your math. So just some notes about that. And that's it. Okay, so I already went over because I wanted to give a little bit about that. So thank you guys for coming. And I do plan on having these at 1 o'clock every, for the whole rest of the term. Seems to be a good time for people, 1 o'clock on Saturdays. So we will keep this time for the rest of the term. So Thank you. I hope you guys have a great day, and I'll try to get this video out to you later today. So, yep, you are welcome.